Hi there, I'm Dave J. Green, and this is the first in a series of videos I'm hoping to do, going through each of the topics in my app, Algebra Tutor. You can download Algebra Tutor now for free on the App Store or on Google Play, and it might be a good idea to have it and to maybe follow along as we go through this tutorial. And sometimes it's easier to listen to or to watch somebody explain something rather than have to read through that explanation yourself. So I'm hoping these videos will be a useful companion to the app. So this video is on the topic called terms, which is intended as an introduction to algebra when we first start using letters to represent numbers. So if you're just starting to learn algebra for the first time, then this is for you. Or if maybe you've learned it in the past but didn't get on with it and have decided to come back in and have another go, then this is for you as well. And so it might be really helpful to watch this video with another person and pause it regularly and take some time to explain things to each other, ask each other questions, try and put things into your own words. That's a really useful process to go through. Mathematics is like this vast world of ideas and concepts that we can explore and link together. And algebra really is just a language that we have devised to help us in that exploration, to help us record ideas and communicate them with each other. So algebra uses symbols and the way those symbols are arranged to convey a meaning. And this is an idea that you are familiar with. You've seen this in other places. So the words art, rat, and tar are all made with the same three letters, A, R, and T, the same three symbols. But when you arrange them differently, you get different words which are attached to different meanings. The digits 0 to 9 are just symbols that represent particular numbers or constants. And there are other ways that we can represent those symbols, such you might be familiar with using dots on the face of dice to represent a particular number, which is, that's fine if you've just got integers from 1 to 6. But imagine if we were to start using that to do things like fractions. So 5/6 and 1/5. We want to multiply them together. Okay, that's 1/6. That's okay. But imagine if I wanted to add them together, I'm going to need a 31/30 domino. So it very quickly becomes practical to use a single symbol, like on this dice, for each of the numbers. And then as we put those digits together, they take on different meanings. The way that they are arranged gives the symbols different meanings. So here, this is just a 5 units. But if I put it next to the 8 like this, then that now means 58. So the 5 now means a 50 instead of 5 units. And similarly, if I swap it around, the 8 changes from being 8 units to being 8 tens. So we're using symbols and the way that those symbols are arranged to convey a meaning to do with numbers and quantities. And in algebra, we simply extend that idea a bit further. We add more symbols and more meanings. 2 plus x means something different from plus 2x, which means something different from plus x to the power 2. The way that we arrange those symbols gives them a different meaning. The Algebra Tutor app is really about learning what those rules are and playing around and experimenting with this new language. So let's go into the topic then. Let's just make this a little bit bigger in case you're watching it on a tiny screen. We're going to go into the topic terms. Here we go. Each topic starts with a message from Mr. Green. So have a read through the message. I'll talk about the progress button when we get there. I've got the skip any section add-on, so I've got a skip and a continue button here. If you haven't got that, you'll just see an OK button, so just click OK. So as you might know, algebra uses letters to represent numbers or to represent unknowns and variables. An unknown is a number that has a particular value, but we may or may not know what that value is. And a variable is a number whose value can change or vary. So, for example, we might have a glass of water. X might represent the number of molecules of water in the glass, which has a definite value, but we don't necessarily know what that is. And T could represent the temperature of the water, which could change as you heat it up or cool it down. So let's have a look at this question. We need to select the lines that contain an unknown or a variable, so the ones with letters in. So that top one has the letter A. That one's just got the numbers, the digits that we're familiar with. That one's got an X. Then that's just numbers, and that one's got a B and a C. So I'm going to select those ones. There we go. Okay. So go and look at the next one. So these next few, I think, are a bit of vocabulary and some definitions, all of which are things that are explored more in other topics, but I just want to flag them up here so you're familiar with these words. So an expression in algebra consists of variables or numbers or both, combined with operations, things like addition and subtraction, multiplication. But an expression doesn't contain equal signs. That's something else I'll talk about in a minute. So looking at these three lines, I need to select the one that is an expression. And so it's the one without the equal signs. There's a collection of numbers and letters and operations in that line. So that's what an expression is. And we'll keep talking more about expressions. Okay. So an equation then, equations do have equal signs. An equation is a statement that two expressions have the same value as each other. So by putting an expression on one side of an equal sign with another expression on the other side, I'm saying those two expressions have the same value. So the example in here is that 2x minus 5 equals 9. Both the expressions, the 9, just the 9, and the 2x minus 5 have a value of 9. And some terminology, we might say an equation in x or an equation in y. That means that x or y is the unknown in that equation. So this question here, select the line that is an equation in x. So I'm looking for the one that has an x in it and is an equation. So it's that one there. Okay, so go on to the next one. So a formula, plural formulae or formulas, I think they're both used. A formula is a special type of equation that expresses a relationship between variables and those, and possibly constants as well. But those letters in those formulas represent particular properties. It might be real life properties. So the example given here is S equals D over T. So that's a formula for the average speed equals the distance travelled divided by the time taken. So I'm looking for another formula in here. Select the line that is a formula. E equals mc squared, quite a famous formula to do with E for energy, m for mass, and c represents the speed of light. And so they are related to each other in some way, which is expressed within this formula. Okay, let's go on there. So that's correct. Okay, and then an identity. An identity is a little bit different from an equation in that an equation tells you that two different expressions have the same numerical value as each other. So two different expressions are the same value. But in an identity, you're seeing two versions of the same expression, or two different ways of writing down the same expression. So the expressions on each side of the identity are the same thing, just written in different ways, which is a slightly different idea to an equation where you've got two different expressions that have the same value. So in this example, x plus x, if you add the same thing to itself, you're going to get 2 of that thing. So x plus x is always equal to 2 times x. And so we're looking for a similar example up here. So x plus x plus x. If you add 3 of the same thing together, you're going to get 3 lots of that thing. So 3x is the same as x plus x plus x. That's 2 different ways of writing the same expression. Okay, there we go. One thing I forgot to mention while filming that is that you sometimes see identities written with 3 lines in the equal sign. That's a slightly different symbol used just to distinguish them from an ordinary equation. So this task here is just flagging up some vocabulary that we might be familiar with from working with numbers, but these are terms that we use quite a lot in algebra. So a number of factors are multiplied together to make a product. So when you've got things multiplied together, that's called a product, and the things that are being multiplied together are called the factors. So all of these lines here equal 24, but only some of them are written as products or factors multiplied together as a product. So the 3 times 8, the 3 and the 8 are the factors, 24 is the product, and the 2 times 2 times 2 times 3 is also 24. That's a series of factors being multiplied together in a product. There we go. Okay, so some notation with algebra then. In the previous example, we saw the multiplication signs between the factors. So we had like 3 multiplication sign and then an 8 to show that we're doing 3 times 8, making 24. When we start to use letters in algebra, we no longer use the multiplication sign to show multiplication. We show multiplication by simply putting things next to each other. So if I put a 5 next to an x, that means 5 multiplied by x, even though I'm not writing down the multiplication sign between them. And there's a couple of reasons that we do that. Firstly, and the main reason is just so that we write less symbols. But also the multiplication sign looks a bit like an x, which is quite a common letter that we use in algebra. You should be able to tell a difference when you write them down. So a multiplication sign is straight, but an x we tend to write as a bit curlier. So placing letters and numbers next to each other means they're being multiplied by each other. So that's quite an important thing about notation in algebra. So if I look at this particular example, we need to select the lines that are products of factors. So similar type of question to the ones before, but this time not all of them will have multiplication signs. So 6 times 2, that's the same as the previous example really, except it's 12 instead of 24. But then some of these other ones are also products of factors without the multiplication sign. So I've got in the next line, I've got -9 multiplied by a multiplied by b. So that's a product. And then I've got an x next to a y, which means x multiplied by y. To take away a, that's not a product, that's a subtraction. But 5 multiplied by x, again, that's a product. That means 5 times x. Okay. So when we have 1 or -1 multiplied by a letter in algebra, we don't write the 1 down. So if you think about how, if you do 1 times 7, that always equals 7. 1 times anything is just going to equal that thing. 1 times -15 is just -15. And the same thing works with algebra. We use that same idea. If I've got 1 multiplied by x, that's just going to be x, so we don't write the 1 down. Or if I've got 1 multiplied by y, that's just y, so we don't write the 1 down. And similarly with -1, if you times something by -1, you just change the sign on it. And so we just write that thing down with a different sign without actually writing down the 1. So select the lines that can be simplified. So I'm going to select the lines where I didn't actually need to write down the 1. I could simplify this algebraic term by not writing down the 1. So 1b would actually just be b, and -1x would actually just be -x. The 11y, that's not going to simplify, although it's got a 1 next to a letter. That's not a 1, it's an 11. Same digits, but a different number. It's somewhere else on the number line. Okay. So this is a question in show me mode. Show me mode means that we're going to select what to do, and Algebra Tutor will show us how it's done. So in this particular task, I need to simplify these expressions. So I'm going to tap simplify, and the app will show me how that's done using its lovely sparkly animations that I spent a long time creating. So the 1, we don't need to write 1 times x, we can just write x. The 5 and the y, the number, oh, I didn't mention that, did I? So when we're showing multiplication with numbers and letters, we always put the numbers before the letters. So I would always write 5y rather than y5. And similarly with the 10, I've got 10 times a times b. The 10 comes first and then the letters. You can put the letters in alphabetical order, that's what the app does. You don't necessarily have to, that's not that important, but always put the numbers before the letters. Okay, and then this one, I'm expecting the 1s to simplify away because we could just write -b or +c. Okay. So exponents, also known as powers or indices, which is the plural of index, they're used to show repeated factors within a product. So rather than write the same factor out lots of times in a product, we just show it once with an exponent or an index or a power written on it. So ab to the power 2 means a times b times b. The b factor appears twice in that product, so instead of writing the b and then another b, we write b with a little 2 next to it. higher up. Okay, so yeah, let's just make sure we're okay with the notation here. So if we've got something like 2 to the power 3 equals 8, then the 2 is called the base, the 3 is the power or the exponent or the index, the plural indices, and the 8 is also known as the power. 8 is a power of 2. So the whole thing can be called a power, or the little number higher up is also called a power, but we usually call that the exponent or the index. So in this question, we're asked to select the lines that are products with repeated factors. So this first one, 7 times x times y, there's no repeated factors there. Same for 6 times x times y times z, no repeated factors there. But y cubed, or y to the power 3, in this one I've got a 5 times an x times a y times a y times a y, so y to the power 3 times a z. So there's repeated factors of the y in that one. This one's also got some repeated factors, so a times b times a again, so the a is there twice. So that one would simplify to be a to the power 2b, and then the 4 would go at the front, so it'd be 4a to the power 2b. And then x to the power 4, again, x is in that product 4 times, so there's x times x times x times x. So hopefully you're familiar with exponents from having, doing things like squaring and cubing numbers. But that's what exponents are. We use them in algebra quite a lot as well. Okay, and this is just going over that notation. So the base and the index making up the power. So select the expressions with an exponent of 3 on a base of x. So I'm looking for a little 3 higher up, and the big number on the main line is x. So this one has 3 on an x. And so does this one. That's got an x to the power 3 within a bigger product, but it's still got an exponent of 3 with a base of x. The others have got x's and 3's, some of them, but not with the base being x and the exponent being 3. There we go. So select the lines that can be simplified. So an exponent of 1 means there's only one instance of that product, in which case we don't really need to write the exponent on there. It's just that product, isn't it? It's just that factor in that product. So when there's an exponent of 1, that will simplify away. We don't need to write the 1. Similar to how we don't need to write the 1 in front of a letter when we've got 1 times a or 1 times x. So which of these ones can be simplified? So I'm looking for the ones where I've got a 1 in an exponent, because I wouldn't need to write that down. I would just leave that exponent out. So that one's got a 1 on the 7x to the power 1, and this one's got a 1 on the a that can be simplified. There we go. So then, again, we're in show me mode. We're going to simplify these, and it's going to show us how to do it. So if I click simplify on this one. So with these animations, you can move the slider backwards and forward. You can pause it and skip to the end if you think you know what's going to go on. Always, maybe before you click the button to show the animation, try to think about what's going to happen, and then watch it, see if that's what you expected to happen or not. So in those ones, we've got rid of the multiplication signs. We've collected together any factors in the same product that are the same thing again, and used indices to shorten it. And we've put the numbers at the front of each term. I'll talk a bit more about what terms are in a moment. Similar thing here. So I've got a b times a b in that first term. So I'm going to write b to the power 2 instead of that. I've got b. Here comes the index of 2. And then there's 4 x's in the same product. So we're going to write x to the power 4. That product's also got 3 y's. So we're going, instead of writing all 3 of them, we're going to just write y to the power 3. There we are. Okay, so this is one of the main reasons that I wanted to leave my job as a math teacher and spend some time developing this app. And this is to do with terms, which is the title of this particular topic. So multiplication, and later we'll see division. Multiplication and division glue things together into the same algebraic term. And plus and minus signs are the start of a new algebraic term. They separate the terms. They begin a new algebraic term. And being able to see within an expression where the terms are is a bit like being able to see where the separate words are within a paragraph of written English. We put little gaps between all the words in English so you can see where all the separate words are. So if you can imagine trying to read a paragraph of English without any of those word gaps in, it was all just one long string of letters, it'd be possible to read it, but it'd be a lot more difficult. And so being able to recognize where the separate terms are within an algebraic expression makes it much easier to read and much easier to do most of the algebraic skills that are covered in Algebra Tutor, things that you're likely to meet. If we don't really understand where the separate terms are, a lot of those skills become a lot more difficult and it can be much easier to make mistakes. So multiplication and division glue things together into the same term, and plus and minus signs are the start of a new term. Those are really important concepts. So in this expression here, there are 3 terms. Each one started with either a plus or a minus sign. And so minus a is the first term. I can sort of tap on each of these terms and I can see them highlighted. So that middle term, the a times a, hopefully you can see that we could simplify that and then it become just a to the power 2. And then the last term is plus 9a, 9 multiplied by a in that last term. So the 9 and the a multiplied together, they're stuck together in the same term. The 2 a's in the middle term, which could become a squared, are stuck together into that same term. But all those plus and minus signs are the beginning of the new term. They're like the first letter of a new word. And this is a concept I'll talk a lot more about in the topic on expressions. Okay, so I've selected the 3 terms. We can see where they are in this expression. There we go. Okay, and then a little bit more vocabulary before we get into simplifying some terms. So a coefficient is the constant or the number, the recognizable number parts, the ones that aren't letters, at the start of a term. And they might take in and include the sign of that term. So what's the example? I can actually move this up and down, so I'm going to just slide that up so we can see it all. So the sign of the term might be considered part of the coefficient. So the term 7x, the coefficient is 7. The term minus 4ab squared, the coefficient is minus 4, and so on. So we need to select the term with a coefficient of -3. So let's go through and look at these terms. So this first one's actually got a coefficient of +3, but notice the plus sign isn't written down, it's sort of invisible. And I'll talk more about that in the topic on expressions, I think. The second term has got a coefficient of -8. This third one's got an x squared, it's got a y in it, they're being multiplied together, so they're stuck together in the same term. But the coefficient, the number part at the front of the term, is -3. So I think this is the one that we're going to want. And then that last term is what's called a constant term. It's just a number, plus 23. Here we go. So when you multiply a number of factors together within a product, it doesn't matter which order those factors are. You can move the factors around within the product and you still get the same product. So like 8 times 3 is still the same as 3 times 8. So where I've got 2 times 3 times 4 within this term, I can do that in any order. So 2 times 3 is going to give me 6. 6 times 4 is going to give me 24. So look at the numbers first, and I'm looking for a term that's got 24 as its coefficient. We've got 24 at the beginning. Okay, and then look at each of the different letters in turn. So this particular term has got an x after the 2 and then another x at the end. So that's an x multiplied by an x, which is going to give us an x to the power 2. And there's a factor of y as well. So I'm looking for a term with a coefficient of 24, an x squared, and a y. So I think it's going to be that one. There we go. Okay, and now we can get into practicing these questions. So the first few will be in show me mode, and it will show you how to do it. And then after that, in step check mode and independent mode, we have to try and figure it out for ourselves. So x multiplied by x cubed. Actually, I can simplify that down to x to the power 4. There are 4 x's in that product. Okay, and then here, again, we've got numbers, so try and sort out those first. So 2 times 10 is going to give us 20 as our coefficient. Then we've got x squared and times another x. So altogether there are 3 x factors in that product, and y is just a y. Let's try this one. again, think about the numbers 6 times 3. What's that going to give us? 18 is our coefficient. And then we've got some a's that are repeated factors within this product. So there are 4 of them altogether, a to the power 4. And then if we want to put them in alphabetical order, we can do. Okay, so hopefully we're starting to get the idea. Yeah, it's doing it for us. It's very nice of it. If we do need to pause it, then we can do. We can sort of slide back and have a look at it again, or zoom forward, skip to the end, whatever. Okay, so now it's changed into step check mode. So I'm going to have to do it myself this time. So I've got an x multiplied by 3 multiplied by another x, and I need to simplify this. So I'm going to tap simplify. So think about the numbers first. So there's just a 3. And then I've got an x times an x, which is going to give me x to the power 2. Mark that, and then we're good. Okay. Right, so again, now look at numbers 6 multiplied by 5 is going to give me 30. And then the letters I've got an a factor and I've got a b factor. I think that's okay. Okay, so I've gone into independent mode now. So it's not going to tell me after the first step if I've got it right or not. It's not going to make a lot of difference in this topic because these questions only have like one step. But step check mode is more useful for topics where there's a series of steps. So you've got to do like solving an equation. So here, 5 times 2 is going to give me 10. I've got x squared times x, which will mean I've got 3 factors that are x's. So I can do x cubed and then y. Not that one. There we go. And this one again, so 4 times 10 is going to give me 40, times by 3 is going to give me 120. Then look at each letter in turn, so I can only see one x, I've got a y, and there's a z squared. Okay, so now we can see the progress button has appeared. So Mr. Green, the algebra tutor, is happy that we could go on to the next section now if we want to. Personally, I would recommend maybe always doing a few more questions at least, just to make sure you've got the idea. But you can practice for as long as you want to within this section. And as you do, you might see the progress button start to get bigger and the go button start to get smaller. But it's up to you when you want to move on, when you feel confident that you've really got the idea and you're ready for the next bit. Okay, so I'm going to press it now. You could carry on practicing if you like. And there's Mr. Green hopping into his hot air balloon and taking us on a journey into discovering the incredible world of mathematics. We're learning this language of algebra to help us to explore this world. And so he's going off in his hot air balloon to try and get an elevated view, which is what we might get as we start to learn algebra. So I might put the next section in another video, which will follow on from this one, I think.